Trig ratios and trig functions. Now we're going to take a look at general and special angles. And the first section of this is angles that are 0, 90, 180, 270, 360, etc. So to take a look at these, let's take a look at a circle. And this circle will be a unit circle. So the radius is 1. And if we have a terminal arm of theta that runs exactly along the positive x-axis, it would create an angle of 0 degrees. And if it ran straight up and down the positive y-axis, it would be 90 degrees. And if it ran across the negative x-axis, it would be 180. Straight down would be 270, etc. 360, around and around and around. So what we're looking at is what happens with our trig ratios in these different directions. And these coordinates are 1, 0, this is 0, 1, this is negative 1, 0, and this is 0, negative 1. So there's your x and your y's, and you know that your r value is always positive 1. So let's take a look and see if we can build a little bit of a chart that will help explain what all of the angles are for all of the different trig ratios. So let's build a chart. And our chart needs to have some of these. So 0 degrees, 90 degrees, 180 degrees, 270 degrees. Of course, 360 degrees is just back to 0. So I don't really need to continue the chart past that. And for some of you, it'll help to have the definitions of all of these. So sine is y over r, and cos is x over r, and tan is y over x. And then these are the reciprocals. And hopefully by now you have all of those memorized. So the radius is always 1. So really, this is just y and r, and 1 over y, and 1 over x. So, y and x, and 1 over y and 1 over x. So now you can just start to look at the coordinates. So at 0 degrees, x is 1 and y is 0. So y is 0 and x is 1. And 0 divided by 1 is 0. And then at 90 degrees, we get y value of 1 and an x value of 0, and the y value divided by 1 divided by 0, we can't have that, so we call that undefined. At 180 degrees, I now have an x value and a y value of negative 1 and 0. So the y value is 0, the x value is negative 1, and 0 divided by negative 1 is still 0. And at 270, I get an x value and a y value that gives a 0 for x, a negative 1 for y, and division by 0 is still undefined. Now, let's take a look at the reciprocals. The reciprocal of 0 is 1 over 0. So that means that this one now becomes undefined. And same with this one. And this one. And this one. For these other ones, cosecant of 90 degrees, that's the reciprocal. It's 1 over 1, which is still 1. And the reciprocal of negative 1 is still negative 1. So as long as my y value exists, I can take reciprocals. And likewise, the reciprocal here is 1, and the reciprocal here is negative 1. I do have with tangent to cotangent some more undefineds. Where it was 0, it's now undefined. And x over y for the ones where it was undefined, let's see what's happening. X over y at 90 degrees. So at 90 degrees, x divided by y is 0 divided by 1, so that's 0. And at 270, x divided by y is 0 divided by negative 1, which is also 0. So you have a couple choices. Some people like to memorize this chart. Other people like to memorize the unit circle and just work them out from the definitions each time. I have a third option for you, but that's a little later in this unit, and so I would suggest either memorizing this chart or memorizing the process of how we built the chart through the unit circle and the definitions to figure these out as you go along. Let's take a look at a couple of examples. Okay, cosine of 3 pi. So I actually like sketching stuff out. So there's 2 pi, and another pi would be that much further. So really I'm dealing with cosine of 180 degrees or cosine of pi. So if you like working in radians, it's cosine pi. If you like working in degrees, this is equivalent to cosine of 180 degrees. And cosine, so if I go this way and I go a unit circle, it's minus 1 comma 0. Cosine is the x value, so this is negative 1. You can double check this on a calculator, and please, please, please do so. So type in cos pi, make sure you're in radian mode, and see if you get negative 1. Then type in cos 180 degrees, making sure you're in degree mode, and get negative 1. I would do that before moving forward at all with this video. The second example is going to be tangent of 900 degrees. So again, this is coterminal to something. That's 360. If I did it again, it would be another 360. So that's 720. And then I need another 180 degrees. So this is really the same as tan 180 degrees. And again, that goes through negative 1, 0. Tan is y over x, which is 0 over negative 1, which is 0, or tangent of any angle is the slope. Y over x is the slope, and this line has a slope of 0. So you can do 0 divided by negative 1, or you can just understand that tan is the slope, and you get 0 from that as well. If tangent went straight up and down, then you get 1 or negative 1 divided by 0, depending on how up and down it goes, and you get the undefined. And if you realize that slope and tangent are the same, then a vertical line has an undefined slope. And so if tangent goes straight up and down, it's also undefined. Okay, let's take a look at some angles besides these ones that are special. Angles of 30, 45, and 60. There are two special triangles that you need to know. One of them is a right-angled triangle with 30 and 60 degrees inside it, and another is a right-angled triangle that has two sides the same, therefore these are both 45 degrees inside it. And they have a particular ratio of their sides. So across from the 30 will be the smallest side, it's unit 1. Across from the 60 is the second longest side, its unit is the square root of 3. And across from the 90, the hypotenuse of this one is 2. Over here, these are both 1, and 1 squared plus 1 squared is 2, and the square root of 2 would be the hypotenuse. So if you want to start calculating some of these special angles, you can do so without a calculator. The sine of 30 degrees, for instance, is opposite over hypotenuse, 1/2. You can check this on a calculator, and since we've just used the calculator to do a previous one, grab it, make sure that sine 30 degrees is equal to 1/2 or 0.5 on your calculator. We are working in degrees. So we could translate this to radians, and we will be doing that in a second in the next example. But you need to make sure your calculators are in the right mode when you are working on stuff. That's one of the most common mistakes in this unit. Okay, speaking of these triangles are exactly the same ratios, so 2, 1, and root 3, and the other triangle of 1, 1, and root 2, even if their angles are a little bit different. And by a little bit different, I mean, well, not different at all, just different in the way that we look at them. So 30 degrees is the same as pi over 6, and 60 degrees is the same as pi over 3, and 45 degrees is the same as pi over 4. and this one would also be pi over 4. So if we are working with these sorts of questions, like find cosine of pi over 4, again, we can do this without a calculator. All we have to do is recognize which triangle it comes from and then do the calculation. So pi over 4 is 1 over root 2. Now, sometimes mathematicians don't like having a square root on the denominator, and we have to rationalize the denominator. Please make sure you do that this year. Let's take a look at a couple more of slightly tricky ones. Okay, this example is cosecant pi over 3, and pi over 3 gives you a clue that we are dealing with a special triangle, namely the one with pi over 3, and pi over 3 is 60 degrees, and pi over 6, 30 degrees, 90. So this is the 30, 60, 90. So this side is 1, this side is root 3, and the hypotenuse is 2. So cosecant is the reciprocal of sine, and sine from the 60 degrees would be root 3 over 2, so cosecant is 2 compared to root 3. Now generally we don't want to have a square root on the denominator, so we rationalize the denominator, and we get a final answer of 2 root 3 over 3. Let's take a look at another example. Cotan of pi over 4, and again pi over 4 gives you a clue that you are using a special triangle. Pi over 4 is 45 degrees, so this is the 45, 45, 90 triangle, which is 1, 1, root 2, and from 45 degrees tan would be 1 over 1, opposite over adjacent, and cotan would be the reciprocal, which is also 1 over 1. Therefore this is 1. Okay, let's move on to another important section called reference angles. Okay, so the first thing, and I think I maybe briefly mentioned this in a previous video, but now we're really going to use this idea of a reference angle. So let me give you the definition, and then I'll walk you through some examples of what I mean by it. For an angle theta that's in standard position, and standard position is just at the end of a terminal arm. The reference angle, and sometimes I use ref with a little angle sign, or the textbook uses theta with a little dash next to it. The reference angle is the positive acute angle. So it's got to be positive, it's got to be acute, which means less than 90 degrees, and it's the angle that's formed between the terminal arm, that's in standard position, of theta, and the x-axis. So if you're in quadrant 1, the standard position angle and the terminal arm and the reference angle are all the same. But if you are in quadrant 2 and this is your angle theta, this is your terminal arm here, your reference angle is this acute angle that's formed between the terminal arm and the x-axis. So this is theta prime, or ref theta, ref angle. So if you're in quadrant 3, that's your standard position angle, but your reference angle is this angle formed between the terminal arm and the x-axis. So this one might be your big theta, 200 degrees, but this little reference angle, well, you got to 180 and then you're just adding another 20. So this little tiny thing in here is your reference angle. We can combine, as I mentioned, this with ASTC, and we can do some fairly complicated questions now. So let's do that.